So in this lesson, we will create the unit circle, which becomes basically the default piece, the tool that you're going to use for evaluating trigonometric stuff this year. So to start off with, we know we've dealt with the degree measures of our exact angles, and now the radian measures of our exact angles. And we've created this, and we can imagine going around it. And if this is 1, and then this is x, well, because this is 45, this also has to be x. And then what I could do is go x squared plus x squared equals 1. Good old Pythagoras theorem, a squared, b squared, c squared. Or 2x squared equals 1, or x squared equals 1/2, or x equals 1 over root 2. If I take the square root of both sides, should be plus minus, but since I know these are only positive values, I can just use the positive one. But to make it easier to see, we're going to rationalize our denominator, multiply top and bottom by root 2, and I get root 2 over 2. So this is root 2 over 2. This is root 2 over 2. And the tan would be the opposite over the adjacent, which are both the same value. So it's going to be 1. I can do the same thing here with my 60 degree or pi thirds. So here, I know that this is 0.5 or 1/2. I don't know what this value is. But what I can do, and I know that's because this is a 60, 60, 60, this would be 1, so halfway across is going to be 1/2. Now to find this piece here, I go c squared equals a squared plus b squared. Where would we be without Pythagoras? And that is lost. And 1/2 squared is a quarter, so 1 equals a quarter plus y squared. Y squared equals 3/4, or y equals root 3 over 4. Again, plus or minus root 3 over 4, but I know that I'm dealing with a positive height here. So my sign is root 3 over 2. And actually, sorry, when I take the square root, that should become 2. Right there, this is going to be 1/2, and this is going to be the opposite, which is here, root 3 over 2, divided by 1/2, so I just get root 3 or root 3 over 1. And then the last thing is I turn my triangle sideways. This becomes 1/2. This becomes root 3 over 2. So now it's 1/2 and 1/2, root 3 over 2 and root 3 over 2, and this would become 1/2 divided by root 3 over 2, which is going to end up being 1 over root 3, 1 over root 3. So these are the exact values we need to have. There are our special triangles, just like that. I made them all correctly. And then they go in here like this. So this is that. This is this. Oh, look at me go. I'm doing that wrong. 1/2 root 3 over 2 and 1 over root 3. Root 3 over 2, 1. I should really pay attention to what I'm doing here. Root 3 over 2, 1/2, and root 3. And this one's your root 2 over 2, root 2 over 2, and 1. Now this seems like an awful lot of information to remember, but the unit circle makes it all easy. If you can count to 4, you can do the unit circle. And if you can't count to 4, then we have bigger problems than the unit circle. If we have the unit circle where my radius is 1, this is going to be opposite over adjacent, y over 1, cosine is x over 1, and tangent is y over x. Or, as I like to say, sine is the y, cosix, the cos is the x, tandem, that's an m. And the m stands for slope. And your slope is delta y over delta x. Since your other point is always the origin, we can just simplify that to y over x. That's your slope. Now, we can organize all of this into this handy-dandy unit e-circle. So, we always like to start with our coordinate points. This is 1, 0, because it's 1 over this way and 0 up. This point is going to be 0, 1. Now, instead of 1, we could write that as root 4 over 2. Why would we want to write it like that? So that it shows us our pattern. So the pattern is count to 4. This one starts at 4, so it's going to count down. 1/2 and 0. I could call it root 1 over 2 if I wanted to. It makes the pattern a little nicer, but is a little, we want to be lazy, so we want to cut out the root 1 when we don't need it. This one we're going to start at 0. For the y coordinates, start at 0 and count up. 1, 2, 3, and 4. Ah, look at that. Count to 4, and you are all set. So this is sine of 0, cos of 1, tan of 0. The tangents we can add in on here are the slopes. There's 3 slopes we need to deal with. This has a slope of 1, which is very nice because it goes through all these points, x, y, that are the same value. This is my shallow one, so it has a slope of 1 over root 3. This is my steep one, so it has a slope of root 3 over 1. So at this point, it's going to be, oh, come on, brain, think here. Pi sixths, 1/2, root 3 over 2, 1 over root 3. Pi fourths, root 2 over 2, root 2 over 2, and 1. Pi thirds, this is counting up, 1, 2, 3, and 3, 2, 1, and root 3, it's the steep one, and now we have 1, 0, and undefined. It's undefined because it's a vertical line. Vertical lines have an undefined slope. Or in terms of the y over x, it would be 1 over 0, again, undefined. You could call it an infinite slope if you really wanted to, since we're all calculus-y goodness. So the sine ratios increase from 0 to 1, and the cosine ratios decrease from 1 to 0. The tangent ratios are equal to the sine ratio divided by the cos ratio, because the sine is the y and the cos is the x. So there is our lovely unit circle. It's the exact same thing. We just count up. 0, 1, 2, 3, 4. Then we count down. 3, 2, 1, 0. 1, 2, 3, 4. 3, 2, 1, 0. Or on the x's, we start at the 4. 4, 3, 2, 1, 0, 1, 2, 3, 4. Again, root 4 over 2 is the same as negative 1, but it fits the pattern more nicely. 4, 3, 2, 1, 0, 1, 2, 3, 4. See, if you can count to 4, you're in great shape. For your tangents, this is my small or shallow line, 1 over root 3. This is my middle line, slope of 1. This is my steep line, root 3 over 1. This one here has a slope of 0, undefined. This is actually the same line. Look at that. So this is also 1 over root 3. This is also 1, and this is root 3 over 1. In these two quadrants, we have the same shallow line, but look, this time it has a negative slope because it's going down and to the right. So this is going to be negative 1 over root 3. Same way all the way down. -1, -1, and I got my colors uncoordinated. That's okay. -√3 over 1, or just -√3, right there. Ba-bam! There is your unit circle. Know it. Love it. Write it out 40 times. This is the way that you do trig. So here's all our formulas, and if r is 1, the sine is the y, the cos is the x, the tan is the slope, and the cotan is 1 over the slope. But just ignore that. So sine 300. Look at your unit circle. It's there. Oh, cool. Whew. You just have to play Where's Waldo on these. So for 300, I look over at my unit circle. Pardon my sneezing. I look at 300, and there's my answer. Cos, sine, and tan. So there's my sine, there's my cos, my tan is -√3, which means my cosecant is -2 over √3, or since they want rationalized, I do all my rationalizing, so -2 √3 over 3. Not that that's any better, per se. +2 over 1, -1 over √3, just doing all of my not inverses, reciprocals. Unit circle to find the exact value of cos of 3 pi quarters. Once you can create the unit circle, you just play Where's Waldo. Here's 3 pi quarters. I found it. Look, it's almost like Waldo with the little red and white hat. I perhaps should not have recorded this with my head stuffy from my cold. But the cos is the x. Sine cosec tanum, so that's going to be -√2 over 2. My cotan of 5 pi thirds. I look back here, I find my 5 pi thirds, which is right here. My tan would be -√3, which means my cotan is -1 over √3. Since tan 5 pi thirds equals √3, then I just flip it over. -√3, sorry. Tan of 600. Well, 600, I have to go, whoop. There's 360, and then a further 240. So that's where I should end up. So I go back to good old unit circleness. 240 is right there. My tangent is √3 over 1. Go back over to here. It's √3. Now if I wanted to check that, let's say I questioned yon unit circle, I could just make sure that I didn't need to do that. I could just go tangent of 600 degrees. Ta-da! Well, that doesn't look like much, but square root of 3, and now ta-da. See, they're the same thing. Or I could take that value and square it and see that it was that. Cosecant of 3 pi. Go back to yon unit circle. Here's going around 1 pi all the way around, 2 pi. And I'll show you that. 1 pi, 2 pi, 3 pi. I'll get rid of it. So, oh, that's not what I meant to do. Back up. Back up. Oh, back up. Yikes. Egads, I have no idea what I just did here. You know what? That can stay. Or I can take it over here. Leave it. Okay. So, fuzzy brain. Cosecant of 3 pi is 1 over sine of 3 pi. 3 pi on my unit circle is going to be right there. The sine is 0, so this sucker is undefined. Use the calculator to find these sorts of things. If I was rotating of 2/5 pi, that's going to be right around here-ish. It's still less than half. So I can go cos -1 of 2 pi divided by 5. Make sure that I'm in fact in radians. I am. I didn't want cos -1, I want cos. There we go. And the sine e cosec tandem. So this point would be 0.3090. My cos is the x. 0.9511. My sine is my y. This class example number 4 is actually rather tricky. So first I have to find this point. Root 2 over 2, common negative root 2 over 2. That's down here. That's my pi quarters family, so this is going to be 7 pi quarters. Then this point, right here, -1/2, comma, root 3 over 2 is going to be here. And it is my pi thirds category. So what I need to do is go counterclockwise from P to Q. Here's my point P, and here's my point Q. There's counterclockwise. So the first thing I'm going to do is go this pi quarters. This whole piece here is pi halves. And then I'm going to go another pi sixths beyond that. That's that piece there. So quarter plus 1/2 is going to be 3/4 plus pi sixths. Here, I'm just going to cheat. 1 divided by 2 plus 1 divided by 4 plus 1 divided by 3. And then I'm just going to math fracket. So that'll be 13 pi twelfths. It also wants it in degrees. In degrees, that's going to be 45 degrees, 90 degrees, and then 30 degrees more. So 90 plus 30 is 125, 165 degrees. And if I wanted to check that that was in fact the same, I could go like this into degrees, and I could go 13 pi twelfths in radians, 195 degrees. What? Crappy. I'll figure it out. All right, I'll figure out what the right answer is later. Anyway, that is the unit circle. Thank you for paying attention to my ramblings, and I'll address the rest in a further video.